Okay, video 2. This will be much shorter than video number 1 was. So we're finishing up doing the Gauss-Jordan method, right? And you have input the system, you've taken the system, turned it into an augmented matrix, put it in the calculator, and use the RREF command. And what you get out looks like one of three things. So the first option, it looks something like this. Now, your calculator won't have the vertical line here, but I'm going to put that in. It makes it a little easier for us to follow what we're doing, okay? So one of them looks like this. What I mean by this is, see, it's all ones right down the main diagonal there. Row 1, column 1 is a 1, row 2, column 2, row 3, column 3, all ones. And then to the left of this vertical line, that's other than the diagonal, it's all zeros. Well, you can just read the answer off. If the variables in the equations were, say, x, y, and z, then you read it off. This says, row 1 says x equals minus 5. Row 2 says y equals 2. Row 3 means z equals 4. So your solution, they call it an ordered triple, would look like minus 5, comma 2, comma 4. This is an independent solution. Okay, and there was one point that solved all three equations. And whenever that happens, this is what it's going to look like. You're going to have the ones down the main diagonal, zeros above and below, and then whatever the answers are out here in the right-hand column, that's what you get. All right. The second type of solution is the dependent. So this is what we're going to look at next, is dependent. And it looks something like this. The main way you can tell dependent is the last row here. See that? Is all zeros. Let's go ahead and put our split down here. All zeros means that last row, there's no information about the last variable. Could be anything. Okay? So again, I'm going to assume our three variables are x, y, and z. So when this last one doesn't do anything, what we do then is we just say that z equals z. All right? Then we look at the second equation here. That's 1y plus 1z equals 8, right? Y plus z equals 8. Solve for y. Y equals minus z plus 8. All right? So we now know that z equals z. Y equals minus z plus 8. So we're going to go and do the same kind of thing now and solve for x. You see what we're doing is we're solving for y. We're solving for the other two variables, x and y. In terms of z, there's going to be a z in them. So this first equation here is x plus 2z equals 11. Now sometimes, see, there's no y in this one, right, because there's a 0 there. Sometimes there'd be a number there and there'd be a y. And ultimately what you would do is you would plug in the y and then you'd substitute in the minus z plus 8 for the y and then go ahead and still solve it, right? You'd have x and all z's then and solve it. Just like we're going to do here. We're going to subtract 2z from both sides. X equals minus 2z plus 11. Okay? Now we're done, because the ordered triple, if you will, the solution to this system will be, so the x is minus 2z plus 11. Y is minus z plus 8. And z is z. And that's it. There's your solution to that system. All right? Again, the key way to determine this, the last row is all zeros. That tells you it's going to be dependent. You plug in z equals z, and then you plug the z in, right? You just plug in and work your way back up the rows. Now this last type of system that comes up, this is the inconsistent one. This is the one that you need to be able to really essentially you just need to be able to identify this one quickly, because there's no solution, there's nothing you can do with it. Again, the key is the last row. You see we have zeros here, right? 3 zeros, and then not 0 on the other side of the bar. Well, this last row, what it essentially says is 0 equals 4. That doesn't make any sense, right? It's 0 does not equal 4. In a way, what this is saying is this system would have a solution if 0 did equal 4, but it doesn't. Anyway, this is what they call inconsistent. So when you see 3 zeros, you know, in your equation side, and then something that's not 0 on your constant side, that excuse me, that means no solution. Okay? All right. So those are the three different types of answers you get from the RREF command for the Gauss-Jordan method on the TI-83 and 84 calculators. The nice thing about this is that it works really for pretty much any system. All right? Okay, that is it for that Gauss-Jordan method.